A third confirmed interstellar object is now racing through our solar system, and astronomers have just captured it live. This mysterious traveler, roughly the size of Manhattan, is hurtling inward on a path that will soon bring it closer to Earth than ever before. NASA and researchers at Harvard have issued an urgent update. New observations suggest that this object, officially named 3I Atlas, may not be traveling alone. Scientists estimate that nearly 4,000 smaller meteoroids or fragments could be accompanying it, forming an enormous debris convoy sweeping through the inner solar system. This discovery is shaking long-held assumptions about interstellar visitors and raising deep questions about what 3I Atlas truly is, and what it might bring with it. The discovery. The story began on July 1, 2025. When telescopes from the Asteroid Terrestrial Impact Last Alert System, ATLAS, in Chile detected a faint, fast-moving object entering the solar system. At first, it looked like a normal comet, a small icy body with a glowing coma. But its hyperbolic trajectory told a different story. This was not a bound solar object. It came from the deep interstellar void and would leave again after passing the Sun. Soon, astronomers noticed something odd. The comet appeared to be losing mass far faster than expected, spewing out gas, dust, and solid particles in a way that didn't fit standard comet behavior. Harvard's findings. Astrophysicist Avi Loeb and his team analyzed the object's changing brightness, gas loss, and trajectory shifts. Their models revealed a surprising conclusion: that thousands of small fragments were following or flanking the main nucleus, forming a kind of interstellar convoy. Instead of one body, 3I Atlas seemed to be surrounded by a loose swarm of fragments, ranging in size from pebbles to boulders. This changes everything. A single interstellar comet is one thing. A cloud of thousands of companions moving together is something else entirely. What this means: if this swarm exists, it dramatically complicates the picture. The debris could stretch across millions of kilometers, spreading along and behind the main body. Each fragment would interact with sunlight, solar wind, and gravity in unique ways, subtly altering the entire system's motion. This makes trajectory prediction far more difficult. The comet is no longer a single, point mass, but a dynamic, living system that must be recalculated constantly. And then there's the risk. Even if most fragments are tiny, the sheer number of them increases the chance that some could drift toward Earth's orbital path, producing unpredictable micrometeoroid activity. A closer look at the composition. Observations from the James Webb Space Telescope, JWST, have revealed that 3I Atlas's coma is unusually rich in carbon dioxide, with a carbon dioxide-hydrogen oxide ratio 8 times higher than in typical comets. That suggests it formed under extreme conditions, perhaps in the cold, radiation-exposed regions far from its parent star. If the swarm fragments share the same chemical makeup, they could provide a rare look at the building blocks of other star systems. If they differ, it could mean the comet has layered or mixed origins, perhaps even incorporating alien dust picked up on its long interstellar journey. An object, ancient, fractured, and luminous, is drifting closer to the Sun. Astronomers have named it 3I Atlas, the third known interstellar object ever discovered, after Oumuamua and Borisov. But this one is different. Because 3I Atlas isn't alone. It's surrounded by a vast swarm of fragments, a moving constellation of dust, rock, and ice, a trail that stretches across millions of kilometers. This is not just another comet. It may be a living archive from another star system, a messenger carrying the history of a world that no longer exists. The fragment swarm as 3I Atlas journeys deeper into the inner solar system. Solar radiation and tidal forces begin to take their toll. Its fragile, icy structure, weakened after countless eons of interstellar travel, begins to fracture and shed material. Each time sunlight heats its surface, plumes of gas and dust erupt into space, feeding an expanding halo that surrounds the object. Some pieces surge ahead, others drift behind, forming what scientists now call the fragment swarm. From a distance, the swarm looks like a faint ribbon of light. But under powerful telescopes, it's something far more intricate, a miniature system in motion, each fragment obeying slightly different gravitational paths. The smaller particles, tiny as grains of sand, scatter sunlight in subtle ways, creating a ghostly glow detectable only in long-exposure images. And as it moves closer to the Sun, this fragile network may stretch for millions of kilometers, possibly brushing near the orbits of Mars or even Earth. But this is not a danger. It's a cosmic encounter, a rare chance to study material that formed around an alien star billions of years ago. The risk factor: NASA's Jet Propulsion Laboratory, JPL, is already watching 3I ATLAS closely. According to their latest models, the comet and its debris swarm will make their closest approach on December 19, 2025, at about 1.8 astronomical units. That's nearly 270 million kilometers from the Sun. At that distance, there's no risk to Earth. But the swarm's behavior adds a layer of mystery. Fragments that break free from the main body are pushed by solar radiation pressure and shaped by the solar wind, changing their trajectories over time. Some may drift across our planet's orbital path months later, too small to pose a threat, but significant enough to create something entirely new, the first interstellar dust shower ever recorded in human history. If even microscopic particles from the swarm reach Earth's upper atmosphere, they could be detected by sensitive radar systems or meteor observatories, marking the first confirmed contact between Earth and solid matter from another star system. Imagine that. Interstellar dust, older than our Sun, falling softly through our sky. The bigger picture, but 3I ATLAS may not be an exception. Scientists are beginning to suspect that interstellar comets, objects ejected from other planetary systems, may be far more common than once believed. Most are simply too faint, too small, or too distant to detect. They drift invisibly between stars, carrying frozen molecules, organic compounds, and stardust forged in alien environments. If 3I ATLAS truly carries a swarm of fragments, then the universe might be teeming with these travelers, messengers of cosmic exchange. Every time one passes through a young solar system, it might seed it with exotic material, carbon chains, amino acids, or other complex molecules, the building blocks of life. This idea ties into one of the most fascinating scientific theories, panspermia, the notion that life, or at least its ingredients, can travel between worlds on comets and asteroids. If true, then the universe isn't just connected by gravity and light, it's connected by biology. A slow, quiet sharing of chemistry across billions of years. A living message from the stars. Every fragment of 3I ATLAS carries a history, a record of the star system it came from. By analyzing its dust, scientists can learn what kinds of elements and isotopes existed around that distant sun. Its magnetic patterns, ice composition, and organic traces could reveal how worlds form, and how they die. In this way, 3I Atlas is not just an object, it's a message in motion. A drifting archive written in frozen atoms, crossing interstellar distances to reach us. As it moves through our skies, we have a rare opportunity to witness and study the chemistry of another solar system without ever leaving our own. Whether or not any of its fragments reach Earth, the knowledge it brings will reshape how we think about the cosmos. Because the universe, as this visitor reminds us, is not static. It's alive, constantly exchanging, evolving, and remembering. Every star, every planet, and every traveler like 3I Atlas is part of that grand conversation.